Well, what does Antarctica have in common with Hawaii? Short little people? No. Well, it's certainly not surfing either. Got it yet? It's active volcanoes. Because of active volcanoes, Antarctica, like Hawaii, is still growing. And compared to the rest of the world, it's still a relative youngster. Our young, very cold continent is a living laboratory full of natural resources and geological wonders. Only problem, most of those resources and wonders are covered by ice year-round. Now, mountains are some of the first things you see in Antarctica. I mean, how could you miss them, right? The reason you see them first is that the most accessible approaches to the continent are on the western side of the Antarctic Peninsula and the Ross Sea area. Further inland, there are still a lot of mountains, but they're mostly buried under ice and glaciers. So how did all these mountains get there? Mostly by volcanic activity. Now, a lot of this activity happened 60 to 70 million years ago and lasted until 35 to 40 million years ago. But today, there are still active volcanoes in the South Shetland and South Sandwich Islands. And Greater Antarctica has active volcanoes like Mount Erebus on Ross Island and Mount Melbourne in Victoria Land. And wherever there's an active volcano, there's new terra firma being formed. So, like the big island of Hawaii, Antarctica is still growing. Give me that stick. At one time, Antarctica was a temperate continent, so natural resources like oil and gas can exist. Only problem, the ground is buried under an ice cover that's an average of 1.5 miles thick, or as thick as 260 football fields. Hey, here's your shovel, start digging. Now, there are deposits of minerals like coal and iron ore, but they're destined to stay buried because it would cost too much to mine them, and the job would be very difficult. Besides, the nations that signed the Antarctic Treaty agreed in 1991 that they would halt the exploitation of minerals by signing the Protocol on Environmental Protection, also called the Madrid Protocol. Now, this agreement banned mining in Antarctica indefinitely. Thanks, Doc. Gopher, Captain Stubing. See you on the Love Boat. So, let's answer the big question. How did Antarctica settle where it is? Well, German scientist Alfred Wegener came up with the theory of plate tectonics at the beginning of the 20th century. Now, this theory has been supported by an overwhelming number of scientific studies. You could also call this theory continental drift. Wegener theorized that at one time, there was only one continent called Pangaea. Now, his theory is that this continent and all the land under the oceans sits on a semi-liquid layer called asthenosphere. This layer is very unstable, so land above and below the water began to break into pieces called plates. Now, these plates began moving apart and crashing into each other, kind of like a geographic demolition derby, or 480 on a weekend, to form mountains, valleys, fault lines, and the continents. So, around 400 million years ago, Pangaea split into these two supercontinents known as Laurentia and Gondwanaland. Antarctica was part of Gondwanaland, consisting of Antarctica, Africa, Australia, and South America. And due to continuing plate tectonics about 200 million years ago, Antarctica started to split away from the other continents and began drifting towards the South Pole. Now, its long, slow journey to the South Pole ended 30 to 60 million years ago. Because of plate tectonics, Antarctica contains fossils of ferns, freshwater fish, amphibians, and reptiles normally found in non-Arctic areas. The majority of Antarctica is within the Antarctic Circle, which is at 66.5 degrees south latitude. The only part of Antarctica outside of the circle is the tip of the Antarctic Peninsula. Now, it sits in the turbulent waters of the Southern Ocean, which begins at 40 degrees south latitude. This is where the Atlantic and Pacific Oceans meet the cold water of the South. And, like the name of our show implies, the geographic South Pole is at 90 degrees south latitude and 0.0 degrees longitude. Its landmass makes it the fifth largest continent following Asia, Africa, North America, and South America, and larger than Australia and the subcontinent of Europe. The United States is about 2/3 as big as Antarctica. There are 30 airports in Antarctica, operated by 16 national governments. Helipads are available at 27 stations. And although it's mostly covered with ice, more solar radiation reaches the surface at the South Pole that hits the equator in the same amount of time. So, that's a bit of Antarctica's geography by the numbers. Antarctica has two major kinds of ice, sea ice and glacial ice. Now, each are formed through different methods. Sea ice forms in oceanic waters when the temperature is lowered to the freezing point of salt water. See, these temperatures need to be colder than 32 degrees, the freezing point for water, for salt water to freeze. Glacial ice forms through the accumulation of snow that becomes compressed by its own weight into solid ice. Sea ice is generally seasonal, while glacial ice can last decades, centuries, or even millennia. During the dead of Antarctic winter, around September, sea ice extends well beyond the Antarctic Circle. During the heart of the Antarctic summer, around February, the sea ice is largely contained within the Antarctic Circle. So, what are all those big pieces of ice found floating around in the ocean? Well, I'm glad you asked. Ice floes are large expanses of floating ice. They're sometimes formed by currents, storms, and tidal movements that buckle and crack what's known as fast ice. Fast ice tends to stay fastened to the shore, to an ice wall, or to a glacier. Others are called tabular bergs, which are formed when a cold spring allows fast ice that has been in place for more than a year to break loose. Then it's called bay ice. When the pieces of bay ice break away, and the sun can be enormous, they drift for years before melting. In fact, 93% of icebergs are found around Antarctica. Glaciers breaking and falling into the sea also cause icebergs. Leopard seals and Weddell seals spend most of their time on the ice shelves or on the pack ice, but are dependent upon ice during much of the year. During the winter, emperor penguins, salute, breed on sea ice and form colonies once the ice is strong enough. Other penguins all breed further north on the land during the summer, but head for the pack ice to live the rest of the year. What about glaciers? They're more complicated than sea ice. The world has had three major periods of intense glaciation. The first was about 650 million years ago during the Precambrian period. The second took place between 250 and 350 million years ago during the Permian period. But the most important one, where Antarctica is concerned, happened fairly recently, during the last several million years, during the Pliocene and the Pleistocene epochs. The polar ice caps developed as the Earth began to cool 150 million years ago. Now, this is the cool part. This cooling lasted until about 3 million years ago. That's it. About 4 million years ago, Antarctic glaciers reached the coastline, and this was the beginning of the Antarctic Ice Age. By the way, 70% of the world's fresh water is contained in the Antarctic ice. It's safe to say that most of Antarctica is covered by ice. In fact, only about 2% of the land isn't covered by ice, and that's mostly barren rock. A lovely choice. Ice, barren rock. Average elevations vary between 1.2 and 2.4 miles above sea level. Some mountain ranges tower above more than 3 miles or above 16,000 feet. That's a little more than half as tall as Mount Everest, the tallest mountain in the world. The highest point is the Vinson Massif, and the lowest, the Bentley Subglacial Trench. So the coldest, windiest, highest, and driest continent is a most inhospitable place to visit. Well, that's it for this edition of Antarctica, 90 degrees south.